Hello everyone, myself Daljit. In this video, we are going to study about physics and I'm welcoming you all on behalf of Physics Made Easy Quota. In this video, first of all, we are going to study about electric flux. So first of all, we consider a surface that having a area capital A. Here are the electric field lines that are crossing through this area that create the electric field here. So electric flux is that which is defined as the how many number of electric field lines that passes through a particular area. So electric flux always linked with the surface through which electric field lines are passing. So as we considered earlier, this surface having the area capital A, let electric field lines that are passing through this area representing the electric field through the plane that having the area capital A, and this plane is perpendicular to the electric field lines. Here we can see that the surface having the area capital A and its area vector is always perpendicular to its plane. So this arrow representing the direction of the area vector, and we can see that there is the angle theta, and theta is the angle between the electric field with the area vector of the surface element. Then we can say that electric flux through the surface element can be given by EA into cos theta. Here cos theta is the component of the electric field which is perpendicular to the surface area. So we can say that the electric flux d phi is equal to the EDS cos theta if we consider the small element of this complete area. To consider for the complete area of this surface element, we can take the integral, and the total flux phi is equal to surface integral of E vector dot ds vector. Suppose we consider a pair of two equal and opposite charges and let them separated by a certain distance. Suppose that distance is 2a, then this complete setup is known as electric dipole. So our next topic is electric dipole, in which a pair of two equal and opposite charges separated by a certain distance are taken. So it is also clear from this example that we take the two charges minus q and plus q and they are separated by the small distance 2a. This distance 2a between the two charges is known as dipole length, and the total charge of an electric dipole is 0. So now moving ahead from electric dipole to electric dipole moment. Electric dipole moment is related to the electric dipole. It is defined as mathematically product of the magnitude of either charge of electric dipole and the dipole length, which means that this relation is equal to the charge q multiplied with the dipole length 2a. Dipole moment is a vector quantity, as the direction of the dipole moment is always taken from the negative to positive charge, and its units can be calculated from its mathematical equation, that is coulomb meter. Coulomb denotes the unit of the magnitude of the either charge and the meter are the units of the dipole length. Suppose we are having the plus q charge and this charge is enclosed in the closed surface, and we are trying to find out the electric flux through this enclosed surface, which means that we want to calculate the total electric flux through any closed surface. Then we use a Gauss law, and we can also consider another example, like there is a point charge small q place inside a cube of h small a. Now, if we want to find the flux through each face of the cube, then again we are using the Gauss law. So what is the Gauss law? What is its main purpose? So here is the definition that Gauss law explain about the total flux linked with a closed surface, and that is equal to the 1 by epsilon naught times the charge enclosed by the closed surface. So we can use the Gauss law to find the total electric flux through any closed surface. In general, the electric field is a basic concept to know about electricity. So we can calculate it by applying the Coulomb's law. But to calculate the electric field distribution in a closed surface, we need to understand the concept of Gauss law. It explains the electric charge enclosed in a closed or the electric charge present in the enclosed closed surface. And we can say that Gauss law is a basic law because we also find the Coulomb's law from it. In fact, both these laws are not two independent physical laws, but the same law expressed in the two different forms. So we can use them to find each other and vice versa. Now the time for the revision. For the revision, there are some questions. The first question is, what is the direction of electric dipole moment vector? Yes, it is from negative to positive charge. Another question is, an electric dipole is formed by plus 5 microcoulomb and minus 5 microcoulomb charges at 4 mm distance. Calculate the dipole moment and give its direction. We already know about the direction, that its direction is from negative to positive charge. And about the dipole moment, we are aware about the formula that dipole moment is equal to the product of the either of the magnitude of the charge multiplied with the dipole length. So we can do the calculations and we get the final answer, and the units can be represented in coulomb meter. So now next question is, so here are the two terms Cm and the Mc. It look like similar, but also it create lot of confusion. So what is the difference in both these terms? For the first one, Cm, it means coulomb meter, and the Mc means millicoulomb. The next question, do Coulomb's law and Gauss laws complement each other? Yes, of course, because Coulomb's law can be derived from the Gauss law and vice versa, as Gauss law is known as the basic law because Coulomb's law can be deduced from it. So dear friends, thank you for watching our video. Take care. Have a good day.